You have to get rid of fluoride. Buy fluoride-free toothpaste, get rid of fluoride in your drinking water, in your home health system or home water system. And then if you're using antacids, you have to stop.
For people who are unfamiliar with nitric oxide, what is it and what role does it play in the body?
Well, I think it's been maybe a couple of years since we last spoke. Not last spoke, since we were on the podcast. I've seen it at several conferences.
Yeah.
But yeah, nitric oxide is one of these fascinating molecules. It's a gas. It's produced naturally in the human body. The older we get, the less we make, and that's what's responsible for age-related disease. But it's and you called it, it's a signaling molecule. It's how cells in the body communicate. Its most common or known function is in vasodilation. So it's produced by the lining of the blood vessels. It diffuses into the smooth muscle where it leads to smooth muscle relaxation, vasodilation. So it controls blood flow and circulation to every organ, tissue, and cell in the body. And when we lose the regulation of blood flow, bad things happen, and it's the earliest event in chronic disease.
Wow. And it plays a role in all kinds of chronic disease conditions, right? Like type 2 diabetes, hypertension, even, I'm guessing dementia and Alzheimer's disease, where vascular dysfunction plays a role.
For sure. So if you look kind of broadly, and I've been in academic medicine now for 25 years, and so we understand, the scientific community understands what causes human disease. We know how to diagnose it. We know how to fix it. So the fact that we don't have a treatment for Alzheimer's and cardiovascular disease, to me, is unacceptable. So the problem is not that we don't know the science, it's that we haven't been able to communicate the science to the healthcare practitioners, the physicians, and then teach them how to teach their patients. So when we look at chronic disease, there's 4 hallmarks of every single chronic disease. Doesn't matter if it's Alzheimer's, cardiovascular disease, diabetes, autoimmune disease. What is that? There's decreased blood flow to the organ, there's inflammation, oxidative stress, and immune dysfunction. And nitric oxide is what controls and mitigates all 4 of those. It improves blood flow. Some of my patents are on methods of reducing inflammation. We know we shut down the fires of inflammation. It prevents oxidative stress, and it mitigates the immune dysfunction that's occurring in those diseased tissues. So it's really the holy grail in terms of cardiovascular medicine. But when we look at kind of so there's a hierarchy of symptoms, right? When you start to develop nitric oxide deficiency, the first sign and symptom is usually erectile dysfunction. And that makes sense because when you lose the ability to dilate blood vessels, which you need to dilate the sex organs to get engorgement, to get an erection in both men and women. When you lose the ability to produce nitric oxide, you fail to get vasodilation, you don't get engorgement, and it's the fundamental basis for erectile dysfunction. So if you have ED, that's not just a sexual dysfunction. It's what we call the canary in the coal mine.
Wow.
If you have vascular dysfunction in the sex organs, you have vascular dysfunction in the heart, the brain, the liver, the kidneys. It's a systemic disease. So if you don't recognize that as a really serious sign and symptom and take steps to correct it, you're now on a very slippery slope to cardiovascular disease, the number 1 killer of men and women, insulin resistance, vascular dementia, Alzheimer's. Every single age-related chronic disease can be traced back to lack of nitric oxide.
Wow. So it is like erectile dysfunction is like the major red flag. Are there others?
Sure. Yeah, typically then if your blood pressure starts to creep up, one of the nitric oxide's fundamental role is in regulation of vascular tone, keeping your blood vessels soft and compliant and being able to dilate upon need. And so when you lose the ability to make nitric oxide, that's the primary vasodilator. So the vessels become chronically constricted. You're now pumping the same volume of blood through a thinner hose.
Wow.
So you develop high blood pressure. And then that leads to damage of the blood vessels, which leads to plaque deposition, atherosclerosis, heart attack, and stroke. So then 2 out of 3 Americans have an unsafe elevation in blood pressure. So it's a huge problem. It's the number 1 risk factor for the number 1 killer of men and women worldwide, which is cardiovascular disease. And then you mentioned one that's near and dear to your heart is dementia and Alzheimer's. And we know fundamentally what causes dementia and Alzheimer's. It's lack of cerebral blood flow, and it's insulin resistance. It's, in fact, by many referred to as type 3 diabetes. And so what does nitric oxide do? It dilates the blood vessels. We can perfuse the brain, and it improves insulin signaling, potentiates glucose uptake, and we reverse the entire metabolic phenotype of vascular dementia and Alzheimer's.
Wow.
And in fact, we have a drug now and going into clinical trials specifically for Alzheimer's.
That's incredible. Erectile dysfunction is something that, just going back to that for a minute, it's something that is fairly obvious to observe if you're a male, right? But what about in women? Because heart disease is still the number 1 killer in women, and women are at twice the risk of developing Alzheimer's as compared to men. So what is like one of those early red flags that women could look out for?
Well, I think it's the same thing when you look at sexual function in women. In order for women to become aroused and stimulated and have an orgasm, you have to have an increase in blood flow. And that leads to an increase in intralabial pressure, interclitoral pressure, and that's what leads to orgasm. So all of that increase in pressure is due to vasodilation from nitric oxide.
Wow.
You can't make nitric oxide, you don't get dilation, you don't get the increased pressure. Women become anorgasmic and they develop sexual dysfunction. But
Damn.
so those, and women, men are somewhat simple creatures. It's typically just a vascular problem. In women, it's hormonal, it's psychological, it's vascular, it's physiological. There are a number of different contributing factors. But it's still, the underlying problem is the vascular dysfunction. You can do hormone replacement therapy, but if you don't fix nitric oxide production in the lining of the blood vessels, then you're only correcting half the problem.
Wow. So what are the primary causes then of this decline in nitric oxide?
It's been one of the fundamental questions I've asked in my research lab for the past 25 years is, how does the human body make nitric oxide? What goes wrong in people that can't make it? What are the clinical consequences? Then how do we fix it? So in order to answer the second question is what goes wrong in people that can't make it, we have to understand how the human body normally makes it. There are two primary pathways. There's an enzyme in the lining of the blood vessels that makes nitric oxide. They're a very complex, it's called a 5-electron oxidation of L-arginine, which is a semi-essential amino acid. So that enzyme becomes dysfunctional with age and time. There's some genetic predispositions that cause it to become dysfunctional, but a lot of it is due to diet and lifestyle. Poor diet, sedentary lifestyle render that enzyme dysfunctional. So we know how to correct that. We know how to recouple the enzyme and restore the function.
What's the name of the enzyme?
It's called nitric oxide synthase. So it's found in the lining of the blood vessels, it's found in our immune cells, and it's found in neurons.
Wow.
So it's part of the neurosignaling and the action potentials by neurons. And the cell signaling is called a presynaptic or a retrograde messenger. It's how these neurons talk to one another.
Don't we also have it, aren't our sinuses enriched with nitric oxide synthase?
So there's a high concentration of this enzyme in our epithelial cells. In fact, it's the basis for blood pressure lowering effects of deep breathing.
Wow.
So mouth breathers bypass this. That's one of the reasons why mouth breathing is so detrimental, because you're bypassing a fundamental nitric oxide production cascade.
Wow.
But if you have a dysfunctional enzyme in the endothelial cells, then that enzyme is dysfunctional in the epithelial cells. So you can do nasal breathing or deep breathing exercise, but if we don't fix that enzyme and make it functional, you're not going to get any nitric oxide produced when you do breathing exercise. So that's what people have failed to recognize is what's the enzymopathy in that enzyme, and then how do you fix it? Because that's really the holy grail in cardiovascular medicine. And then, so that's one way we become nitric oxide deficient. The other is kind of the aha moment for most people. Because about 20 years ago, we recognized that there's an enterosalivary circuit, right? So the mechanism of action of certain dietary patterns, whether it's a plant-based diet or Japanese diet or Mediterranean diet, we're consuming a lot of inorganic nitrate. And then this molecule is inert in humans. So humans cannot process this molecule. We're 100% dependent upon the bacteria. So there's bacteria on the crypts of the tongue that metabolize nitrate into nitrite and nitric oxide. So if you don't have the right oral microbiome, you can consume these vegetables, but you don't get the nitric oxide benefits of it. And here's where the problem comes in. Mouthwash. 2 out of 3 Americans use mouthwash. 2 out of 3 Americans have an unsafe elevation in blood pressure. And we published, I think, in 2015 that this is causal for hypertension. So when you eradicate these essential commensal nitrate-reducing bacteria, it causes an increase in blood pressure. The other problem is fluoride. Fluoride's an antiseptic, kills the bacteria. Most people put fluoride in their toothpaste or using fluorinated toothpaste. There's fluoride in municipal water. Fluoride's an antiseptic, it's a neurotoxin, and it kills your thyroid function.
Yikes.
So we have to get rid of fluoride.
Yeah.
I mean, it is a serious toxin.
Dude, you are the one who turned me on to this whole mouthwash thing.
Yeah.
And I had the privilege of getting to go on the Joe Rogan podcast and talk about it. Because, I mean, since you brought it up on my podcast, I mean, it's a rabbit hole that I was happy to go down because it's just so fascinating. So just make it if you can, I mean, you've already made it so clear, but just walk us through this again. How can mouthwash, something as benign, right? It's sold over the counter, right?
That's right.
Does over the counter mouthwash have this effect?
Absolutely. So here's what happens, and the advertisements are correct. Kills 99.99% of the bacteria when you use it.
And that's the problem.
That's the problem. I mean, the bacteria that live in and on the human body outnumber on human cells 10 to 1, right? So this is an entire ecology. We call this symbiosis. These bacteria providing metabolic benefits to the human host that we can't do. One of those is production of nitric oxide. So when you eradicate these bacteria, there's an entire ecology from the mouth all the way down to the anus, right? And it's the microbiome. A lot of people focused on the gut microbiome. Years ago, we focused on the oral microbiome. And what we found was that the more diverse the microbiome, the better cardiovascular health and the better blood pressure management. So when you eradicate this with mouthwash, we saw, I think the first paper was in maybe 2009, 2010. You take normal intensive patients, you just put them on mouthwash twice a day for 7 days, you see an increase in blood pressure.
Damn.
Now this drove kind of cardiologists and vascular biologists crazy because they thought we thought we had a pretty good understanding of vascular biology and maintenance of systemic blood pressure. So how, by killing oral bacteria, we're affecting systemic blood pressure and vascular tone? And then we figured out, well, it's through the production of nitric oxide. So yeah, alcohol-based mouthwash does this. The chlorhexidine prescription mouthwash is very effective at killing it. The good news is, and we published this in 2019, if you use mouthwash, we certainly see an increase in blood pressure. And I think in 2020, I was on the doctor show. We came in and we revealed that if you use mouthwash, you actually lose the protective benefits of exercise. So think about this. If you're trying to do all the right things, you're eating a good balanced diet, you're getting exercise, but if you're using mouthwash, you lose the entire cardiovascular benefits of everything you're doing. The good news is 4 days after we stop using it, blood pressure normalizes, the bacteria completely repopulate. So this is a resilient community that just let them do their job, leave them alone. There's a reason we don't take an oral antibiotic every day for the rest of our life. There's known systemic effects of this, right? So it doesn't make any sense to use an oral antiseptic every day for the rest of our life. Yet 2/3 of Americans wake up every morning and use mouthwash.
Shocking.
And so to me, it's no wonder why Americans are the sickest population on the planet.
But they'll sometimes market these mouthwashes for people with diabetes, right? Like that seems to be misguided.
It's counterintuitive. No,
it's
in fact, it's making it worse.
And misguided, and making it worse, as you suggested, if nitric oxide plays a role in insulin signaling, right?
Well, we have to look back and think about historically what caused this, right? What caused medicine to do the things they're doing today? And most of the time there was good reason, right? So 50, 60 years ago, there was a recognition of an oral systemic link, right? That patients who have periodontal disease, gingivitis, have a higher incidence of heart attack and stroke. So they immediately assumed that it was the pathogens in the gum that translocated, got systemic, caused vascular inflammation, plaque instability, plaque rupture, heart attack and stroke. So then the thought was, well, if that's the case, then we need to kill these bugs, kill the pathogens. But that was long before we understood the entire microbiome. So when I ask dentists this all the time, and I speak at a lot of dental events, why do you still use fluoride rinses and why are you still prescribing chlorhexidine or mouthwash to your patients? And they go, well, that's just the way we've always done it. Well, in medicine, years ago we used to use leeches for exsanguination, right? We don't do that anymore because we have better methods and we know the science. The science advances. So we have to be able to apply the innovations in basic science and translate that into clinical medicine. And the only way to do that is to take this new information, pivot, realize that, okay, maybe what we weren't doing was working because people aren't getting better going to physicians and taking medicine. In fact, they're getting worse. And from a scientific standpoint, we understand the mechanism of disease today that we can fix every single chronic disease. Well,
also, like, medicine is known for taking this reductionist approach where the different organ systems of the body are siloed off and studied unto themselves. But if there's anything that the microbiome has shown us is that everything is connected.
Yeah, the knee bone's connected to the hip bone, right?
Yeah.
Heart's connected to the mouth, to the lungs, to the sex organs. I mean, we're all connected through the cardiovascular system. And when that fails, then you get end organ disease and the human body fails.
So what happens then when we eat a meal or a dish, a bowl of dark leafy greens, for example, rich in these inorganic nitrates? Like,
kale, your favorite?
What? Kale?
Your favorite kale?
Oh my God. People always pick on me for, I enjoy kale. I mean, is that the only dark leafy green that I like? I like arugula. I like the mixed organic greens.
Yeah.
But yeah, so walk us through this process. What's happening, as we lift the forkful of kale, we'll say, to our mouths.
So this pathway was first discovered in the 1970s. And so these were cancer biologists trying to understand the etiology of oral cancers. And at that time, it was thought that nitrate would form nitrosamines, which would intercalate DNA, cause mutations, and cause cancer. And then they recognized that the human body actually intentionally concentrates nitrate in our salivary glands. The kidneys reabsorb it and concentrate in our salivary glands. So the body doesn't make mistakes, right? Why would we intentionally reabsorb a molecule and then concentrate it in our salivary glands? Because they thought, okay, that's contributing to certain oral cancers. Well, fast forward 30 years, and now we recognize that the salivary glands secrete nitrate so that the bacteria living in the crypts of the tongue can metabolize this, and these are facultative anaerobes. So when there's no oxygen around, they respire on nitrogen in the form of nitrate.
Wow.
And then this 2-electron reduction forms nitrite in our saliva. So now when we swallow our own saliva, we get a burst of nitric oxide in the lumen of the stomach.
So we've evolved a pathway to feed the bacteria.
That's right.
In our own mouths?
Yeah, it's a prebiotic. It's an endogenous prebiotic. And it's made to recycle and reproduce nitric oxide on a continual basis. So this pathway is dependent upon, number one, getting enough nitrate from the diet, number two, the presence of the right oral bacteria, and number three is the presence of stomach acid. And so when you use stomach or antacids, you completely shut down nitric oxide production. So under normal conditions, if you're healthy, if you're eating a good balanced diet in moderation, you have the right bacteria and you have stomach acid production. When we consume that meal, and it takes 90 minutes from if we eat a salad where there's spinach or any nitrate-containing food, 90 minutes after we consume that, we can start seeing secretion of nitrate in our salivary glands. And now for the next 6, 8, 10 hours, each time we salivate and swallow our own saliva, we get a burst of nitric oxide in the lumen of the stomach.
Whoa.
And that nitric oxide that's produced in the stomach kills things like H. pylori, the ulcer-causing bacteria. If you've got some E. coli or salmonella or some pathogen on your salad or greens, it'll kill that. It enhances gastric mucosal blood flow, so you enhance nutrient absorption. It prevents ulcers from chronic NSAID use. I mean, it's a fundamental physiological process that we interrupted at our own demise. And so now we find that there's, people who have been on antacids for 3 to 5 years have a 40% higher incidence of heart attack and stroke. That's not increased risk, that's actual events.
Wow.
And a study out 2 weeks ago showed that people have been on proton pump inhibitors for 4 years had a 40% increase in dementia.
Wow.
And rapid onset of Alzheimer's. So these drugs really, there should be a black box warning on them. These drugs were never approved by the FDA for long-term use. They were only approved for acute use for gastroesophageal reflux. But now you can buy them over the counter. People have been taking them every day for 5, 10, 15 years, and the consequences are deadly. So these are very dangerous drugs that should not be used.
I mean, antacids, they also block B12 absorption.
Yeah, without stomach acid, you can't absorb iron. You can't absorb B vitamins. You can't absorb magnesium. You can't absorb iodine. You can't absorb selenium, chromium. So we become nutrient deficient. We interrupt cell signaling, insulin signaling. We become insulin resistant. We shut down nitric oxide production. We develop autoimmune disease. Without stomach acid, you can't break down proteins into amino acids. We get peptide fragments absorbed across the gut. We develop antibodies against it. That's autoimmunity. And it's all caused by lack of stomach acid production.
Wow. How do we increase? I mean, say you're not on an antacid. You don't take an antacid regularly. Are there any ways to boost stomach acid production? I get asked this quite a bit, actually.
Well, as a biochemist, we got to look at reactions, right? What is the chemical reaction in the parietal cells that make hydrochloric acid? And so that chemical reaction is very well elucidated. We need iodine. We need betaine hydrochloride. We need zinc. And we need B vitamins. And we need carbon dioxide. And the parietal cells make carbon dioxide or make hydrochloric acid. But if you're on antacids, you can't absorb iodine, you can't absorb zinc, you can't absorb B vitamins. So there's no way that your body can make stomach acid if you're on an antacid.
Wow.
Because you don't have the nutrients to do it to fuel that reaction.
Yeah.
So then what we have to do is we have to supplement the body. And the whole kind of paradigm I work on is called restorative physiology, whether it's drug development or product development. Give the body what it needs, get out of the way. The body's a lot smarter than we are, and the body heals itself. So tell people you got to supplement with iodine. Most people are deficient in zinc, B vitamins. And now the parietal cells have what they need to secrete hydrochloric acid, and you overcome all the problems of nutrient deficiencies and nitric oxide production.
I had no idea that iodine's role in stomach acid production. I mean, I was familiar with its role in thyroid hormone production.
Yeah.
But
when you're deficient in iodine, I mean, you get thyroid dysfunction, you develop autoimmune, you develop achlorhydria in the stomach, and everything that occurs thereafter.
What are some sources of iodine?
Kelp, seaweed. You can't get enough iodine in iodized salt to fuel everything you need to convert T4 to T3 active thyroid hormone. There's not enough iodine, and really Americans are deficient in iodine. We found that the Japanese diet is probably the only population diet out there that's getting enough nitrate from their food supply. And that's why I supplement with iodine every day.
You
12.5 milligrams, because the American diet and the food that we eat in America is basically devoid of any iodine.
Yeah, well, I mean, unless you're eating a ton of sea vegetables,
that's
right?
Or fermented foods.
Or fermented foods, yeah. I mean, I know egg yolks contain some, but I don't know how much. That is wild. Really good to know. Because, I mean, sometimes people ask me, they have difficulty digesting animal products, for example, some.
Yeah.
My go-to response, my sort of like cookie cutter default response is usually like, you should check out your stomach acid. You know, that's a big,
for sure,
issue. But somebody who has, for example, been on like a low meat diet for some time probably is not regularly getting adequate amounts of zinc, iodine,
B vitamins.
Yeah, so it's like creates this vicious cycle, right? You don't eat a lot of animal products, so then the machinery to digest animal products winds down.
That's right. Yeah, our body adapts to what we give it.
Yeah.
Right? And so if you hit your body with something that's not used to seeing, it's going to take a while for it to adapt. So we have to give the body what it needs and heal it. So I tell people, my response is take some apple cider vinegar before a meal. So that's acetic acid. 1 tablespoon's enough. It'll acidify the lumen of the stomach. Now you're acidic, and you can break down proteins into amino acid. You can properly digest food. You can properly absorb nutrients. And it fixes a lot of the problems until your body's able to secrete stomach acid on its own.
Wow. That's incredible.
Yeah, so I tell nitric oxide is foundational. But if you're deficient in stomach acid and iodine, nitric oxide is foundational, but it's not a silver bullet. It's not going to fix these other problems. But I think what we're finding is the body cannot and will not heal without nitric oxide production and improving blood flow and reducing inflammation. But you still have to address the other deficiencies, the other problems, the other toxins that you may be exposed to, the other nutrient deficiencies. So this is just kind of like laying the groundwork for the body to heal. But the physicians and the practitioners still have to do the investigative work and figure out what exactly is causing this particular patient's problems.
Yeah. But, I mean, when you acknowledge that the gut starts in the mouth, I mean, this is just really, really empowering information. One area where you blew my mind, I mean, you're just like, you have all this incredible information to deliver, but one area in particular that I found fascinating about our first chat was we talked a bit about nitrites in processed meat, right? Because processed meat is very controversial. Some people believe it to be like the devil incarnate, and others will, regularly use it for the valuable source of protein that it is, right?
Yep.
But one, I think, chemical that does seem to that there seems to be, I guess, more agreement on than not is sodium nitrite, which is added as a preservative in processed meats. And a lot of people tend to like avoid that as a compound. But you've published papers suggesting that this isn't actually the dietary boogeyman that it's often made out to be.
It is a cure. It's an actual cure.
It's
a curing agent to meat, and it cures the human being of disease.
Okay, this is fascinating. So and highly controversial.
Yeah. Well, let's go back historically. Again, there's a reason for the way things were done. If you go back thousands of years, long before refrigeration, when early humans were hunters and gatherers, they killed the buffalo, they killed the deer. There was no refrigeration, so they had to preserve the meat to get them through winter. What they found way back when, thousands of years ago, that they would preserve it with sea salt. And they thought that the salt was just reducing the moisture content of the meat and preventing spoilage and all that. Well, come to find out that the sea salt actually had nitrate and some nitrite in it. It's a natural salt, potassium nitrate, what we call saltpeter today. And that led to the curing. So you would cure the meat. There would be bacteria that were naturally on the meat. Then those bacteria would reduce nitrate to nitrite, and you would get nitric oxide that binds to the hemoglobin or the myoglobin of muscle, and that creates the nitrosyl hemochroma pigment that causes the pink color and the red meat curing. So when it preserves the meat, it prevents food spoilage, it prevents bacteria overgrowth, prevents foodborne illnesses. So it's absolutely essential for ready-to-eat meats and any processed meats. In fact, for decades now, the meat industry is trying to figure out how do we get rid of nitrite because of the misinformation by the media. And you cannot live without it. I mean, if you took nitrite out of cured and processed meats, then you would have more Americans dying from salmonella, E. coli, botulism than ever before. So then the question was, then fast forward to the 50s and 60s, and nutritional epidemiology came about, right? And nutritional epidemiologists take observations from populations of people and look at their incidence of certain diseases. So they found that people who eat kind of a more cured meats than others have a higher incidence of gastrointestinal cancers, whether it's colon cancer, stomach cancer. So these are observations and they're associations, but associations are not causation. So there's a series of steps you have to go through to establish causation. One of those is, there's an observation. And by the way, it's a very small increased risk. So relative risk is different than absolute risk, and it's a statistical kind of a deception.
Can you give us an example of that, like where?
So let's say if you've got a clinical trial and you say that in the control group that was eating cured meat, let's say 1,000 patients, and in that 1,000 patients, 998 people developed, or 2 out of those 1,000 developed stomach cancer. And then in the control group, only 1 out of 1,000 developed stomach cancer. So the absolute risk is 0.001, right? But if you take the relative risk, there's a 100% increase in risk. Because that group went from 2 that had cancer in the cured meat and only 1 in the control.
And it's 100% that makes headlines.
It's 100% it makes headlines.
Right.
Otherwise, an absolute risk of 0.001, it's within the noise. And there's so many other confounding factors. That's the problem with nutritional epidemiology and relative risk, and reporting this as relative risk. It's a deception. So you have to look at absolute risk. And actually what we look at is the number to treat. How many people would you need to treat or intervene to actually see a reduction in the disease process? So that's a whole nother subject matter that people don't understand. They just read the headlines, and those are headline-grabbing numbers. But the next step in that was, what's a biologically plausible mechanism to see that observation, to establish causation? So in the 50s, it was recognized that nitrite can form nitrosamines. Nitrosamines can cause cancer. So that was their established biologically plausible mechanism. But then in the 1980s, it was recognized that the body actually produces nitrate and nitrite. This was the first observation, and really one of the first observations that led to the discovery of nitric oxide.
Wow.
So if nitrate and nitrite were cancerous carcinogens, why would the human body naturally produce them? So it starts shooting holes in their whole hypothesis. And then the other observation was from vegetarians, people who eat a plant-based diet, have a 10 times less reduction in risk of cancer and cardiovascular disease. So if nitrate and nitrite and cured and processed meats cause cancer, vegetarians would have a 10 times higher rate of cancer than meat eaters. In fact, we see pretty much the opposite.
Wow.
Because 85% of the nitrate and nitrite we get from our diet comes from green leafy vegetables.
Vegetables, right. So
5% comes from cured and processed meat. The other 10% comes from swallowing our own saliva.
Right. So you're saying that if this is true, then we would expect to see dramatically higher rates of these kinds of GI cancers in vegans and vegetarians who are ingesting a lot more inorganic
nitrate.
That's right. Super interesting.
Yeah. So it goes back to the fact, this may be surprising, the media is not always honest with us, right?
Very shocking.
And we're getting a lot of misinformation. So this whole story of nitrate, nitrite, nitrosamines, and cancer has completely fallen apart over the past 30 years. And it was really the discovery of nitric oxide, and that these compounds actually nitric oxide precursors. And in fact, I've argued for the past 20 years that these are indispensable nutrients, that we need nitrate and nitrite. So I tell, and I've consulted for Kraft Oscar Mayer and tried to figure out ways how to do this. And I go, look, you shouldn't be running away and creating these nitrite-free bacon, nitrite-free hot dogs. You should lead with it, advertising it. I'm developing this compound as a drug. We're developing these as functional nutrition products. And in fact, we've measured this, and we published this in 2009. Nitrite-free bacon has 5 times more nitrite than bacon with sodium nitrite added to it.
Whoa. Where does it come from? The celery powder or whatever?
Yeah, so here's the game. To get a no nitrite label, you just can't add sodium nitrite. So what do? They use celery salt, which is high in nitrate. And then they put a starter culture of a bacteria called Staph carnosus on that broth, and the bacteria reduced the nitrate to nitrite. So it's the nitrite that comes from nitrate that cures the meat, but they didn't add nitrite directly, so it's no nitrite added meat.
Wow.
But yet, now you've got a problem with the variability of the bacterial reduction. You still have some bacteria present in that food, and the shelf life isn't as long. So it's not a better product. It's a more expensive product, but it's certainly not a better product. So I tell people, save your money. Don't spend the extra $2 a pound or whatever it is now to buy no nitrite or organically cured or whatever they're calling it now.
But so what is the process then by which these nitrites become nitrosamines in the body? Like, when you fry bacon that has sodium nitrite in it at high temperatures, I'm not a chemist, but like, isn't there some kind of reaction that converts these compounds to nitrosamines?
Yeah, here's the chemistry. You've got to have a certain set of conditions or reactants present for this to occur. So and it's not nitrosamines in general. So it's only secondary amines, right? So this is a certain type of low molecular weight amine. So primary amines, they typically rearrange to alcohols. They're non-reactive. Tertiary and quaternary amines, there's too much steric hindrance for the nitrite to react. So they don't worry about it. So the only thing we worry about are secondary amines because they're small, they're low molecular weight, and nitrite can react to form nitrosamines. And then those nitrosamines, and there's a handful of these that are known carcinogens and that are mutagenic and cause cancer. So I don't dispute the fact that nitrosamines are bad. So what we have to understand is there endogenous formation of nitrosamines in the food we eat? So number one, you have to have nitrite. Number two, you have to have the presence of secondary amines, which there typically are none in meat products. I mean, you can add dimethylamine and form nitrosyl dimethylamine, which is a huge liver carcinogen, but that's not naturally present. The other thing, once they realized this chemistry, was that vitamin C and polyphenols and vitamin E are potent inhibitors of nitrosative chemistry. So even if you have a secondary amine around and you've got nitrite, if you've got a certain amount of ascorbic acid or vitamin E or polyphenols, it completely 100% inhibits that reaction.
Wow.
So you don't get any nitrosamine formation. And I believe it was 1972, the Code of Federal Regulation changed to where any nitrite-cured meat product, you had to add ascorbic acid to prevent any potential nitrosative chemistry. So now they use erythrobate. You'll see erythrobate on bacon and hot dogs. And that's kind of we call it an accelerant because it accelerates the 1 electron reduction of nitrite to nitric oxide, which is the actual curing agent. And it prevents any nitrosative chemistry. So now there's no cause whatsoever. So you're getting efficient nitric oxide production, you're getting efficient curing, and really there's no residual nitrite left in a cured meat product. It's the NO that's bound to the heme of myoglobin. In the meat muscle itself, there's hardly any residual nitrite.
Wow. Sodium nitrite, actually, you're saying...
Is a cure.
Is a cure. Very interesting. So do we see like a reduction of... Do we see any of the benefits that we would see from an acute boost of nitric oxide after the consumption of processed meat, for example, with nitrite in it?
No, because there's so little in there, right? It's all reacted in the form of NO bound to myoglobin. The other thing is that, this is a complex matrix, right? You got proteins, you got fat, you got a lot of extracellular material in meat muscle. So it's a complex food to digest. But you don't get enough nitrite or nitric oxide in cured and processed meats to really provide any therapeutic benefit. And I think that's the reason that we should eat a balanced diet in moderation. And historically, I've written about this. The societal norms is you eat your salad before you eat your steak. Why is that? Well, the salad's providing the nitrate, so by the time we're digesting the protein from the steak, we've 90 minutes and we've got the nitric oxide being produced. We're protecting the vasculature from the postprandial inflammation and oxidative stress.
The French do it the opposite way.
Well,
right?
Who explains the French?
I don't know, but French paradox, right?
Yeah.
Actually, the French paradox is interesting. It's not as paradoxical I think, as we once thought it was.
Right.
They eat a lot of cheese. They eat a lot of, they eat a lot of saturated fats, but saturated fats that are bound to this, what's called the milk fat globule membrane, which we're seeing is actually benign from a cardiovascular standpoint. And so they have like pristine heart health.
And they smoke a lot. They drink
do
wine.
Smoke a lot. Yeah.
But they're active. Europeans exercise a lot, right? They walk everywhere.
Yes. Yeah.
And so I think it's, we have to move. We have to exercise. We in America, we go to our restaurant, we engorge ourselves, we drive home, and we never walk, and we go to bed full. And so it's just a constant battle.
There's a lot of there are a lot of pre-workout supplements on the market that claim to boost nitric oxide. Is there any merit to those claims in your typical pre-workout product? And for people that do like to lift, your boy being one of them, what is a good way to boost nitric oxide pre-workout?
Well, again, let's go back to 98 when the Nobel Prize was awarded. That's when nitric oxide really hit kind of mainstream. So in 92, it was recognized as Molecule of the Year by Science Magazine. So it was gaining some momentum in terms of the scientific community, but still very little public awareness around it. And then in 98, a Nobel Prize was awarded. Then people got excited about it. And then it was recognized that there's an enzyme called nitric oxide synthase that converts arginine to nitric oxide. So the market was flooded with arginine-based products they called nitric oxide. The problem with these products are arginine is a semi-essential amino acid, right? Meaning that it's produced within the human body through the urea cycle. And then we get arginine from our diet, from plant proteins, animal proteins. It's one of the amino acids that make up proteins. So when we eat a protein diet, we get arginine. When we have normal cycling and flux through the urea cycle, we make arginine. The body's never deficient in arginine. So it doesn't make sense to supplement arginine. In fact, now there's clinical data out showing if you supplement high-dose arginine to patients that had a previous heart attack or peripheral artery disease, they get worse. In post-infarct patients, it killed more patients than the placebo, giving arginine.
Wow.
So arginine should not be recommended for patients with endothelial dysfunction. So if you don't have endothelial dysfunction, which well-trained athletes have good endothelial function, and there's some evidence out there that if you give a certain dose of arginine, you can kind of push a little bit of nitric oxide and get some out. But again, arginine is never the rate-limiting step in nitric oxide production. It's the function of the enzyme that converts it to nitric oxide. So those products don't work. Those were big for probably 15 years. And then in 2012, in the London Olympic Games, it was recognized that people were drinking gallons of beetroot juice, right, in the London Games. And in fact, the UK Olympic team won more medals than any time in the history of the Olympics. And they attributed it to drinking their beet juice.
Wow.
So then the market was flooded with beetroot products. And now there's hundreds of beetroot products out there that are sold as pre-workouts. I've tested probably all of them. 99% of them do nothing but turn your pee and your poop pink and cause a lot of anxiety. Interesting.
I wonder if it's because you're drinking it and it's just like, right down the gullet. It's not, those products aren't allowed time
the companies that are marketing these don't understand the science. They just think beet juice, they go out and buy the cheapest dehydrated beetroot product they can and sell it for 10, 15, 20 bucks. You have to have sufficient nitrate in it. You have to have the right bacteria, and you have to have stomach acid. And as we've already elucidated, most people don't have the right bacteria, and most people are on antacids, so they're not going to get a nitric oxide benefit from that. In fact, most of these beet products don't have any detectable nitrate or nitrite in them.
Wow. Damn.
So there's no way they can work.
Wow.
It's just creative marketing.
Fascinating.
So we understood the science, and back in 2012, I recognized this, and I developed my own fermented beet powder. So what we do is we convert it. We don't rely on the human body to convert it because everybody would have a differential response. I'm not interested in bringing to market a product that only works in a third of the people. We have to maintain the integrity of the science and provide safe and effective products that everybody's going to get the same effect. So we pre-convert our beetroot product into a bioactive nitric oxide. So when you put it in water, we generate nitric oxide gas. When you consume it, we're liberating nitric oxide systemically.
Wow.
We're not dependent upon the bacteria. We're not dependent upon your ability to produce stomach acid. We generate nitric oxide for you.
Wow. And what's the product that you gave me that has, it's like literally sodium nitrite and vitamin C and all this stuff, and it's like swallow your saliva after. I've been taking it pre-workout. And
so that's our lozenge.
Okay, cool.
So that was the first product that I brought to market. And that came from kind of my first eureka moment in science. And in 2007, we published the first paper showing that nitric oxide was a hormone. Right? So if you're deficient in other hormones like testosterone or estrogen, what do? We have to take it. Right? Same thing with nitric oxide. If you're deficient in nitric oxide production, we have to give you nitric oxide. And we have to fix your body's ability to make it on its own. So that was the whole basis for me developing a product technology that, number one, if your body can't make nitric oxide, we got to do it for you. As I mentioned earlier, we understand the enzymology and the biochemistry that we can fix the enzyme in the lining of the blood vessel. And now we know how to repopulate these bacteria. So I developed this orally disintegrating tablet that you put in your mouth. It dissolves over 5 minutes. You just move it around, and we're providing nitric oxide gas. So as it's dissolving, we're generating about 30 parts per million nitric oxide gas.
Whoa.
It's not hoping your body can convert it. We can detect it, we can quantify it, we can verify it. So, and then the other important thing is we recouple the NOS enzyme, so we see about a 15% improvement in your body's ability to make it 4 hours after the lozenge. And then we're repopulating the good bacteria in your mouth.
Wow.
So it's just the opposite. So so theoretically, people would need less and less of my product over time. Because as we're fixing your body's ability to make it, the less you need supplemental.
Interesting. You said it takes about 90 minutes for a high nitrate meal.
That's right.
To boost nitric oxide. Is that the same time frame that it takes for one of these lozenges to kick in?
No, the lozenge is immediate.
Wow. Yeah, because I've been taking it like literally as I walk into my gym.
And so we can see if we use an ultrasound of your carotid artery, when you put that lozenge in your mouth, within 12 seconds, we can see your carotid artery dilate.
Whoa.
So it's immediate dissolution, it's immediate vasoactivity, and you get systemic effects.
Is nitric oxide the answer to hypertension, to all? I mean, it's like we're seeing such staggering rates of metabolic illness. Yeah. 1 in 2 adults today have hypertension.
Yeah, and 2 out of 3 have either pre-hypertension or hypertension.
Wow.
So yeah, I think there's different causes for hypertension, right? And if you look at different class of drugs for antihypertensive medication, the first kind of, I think, effective drugs on the market were affecting what's called the renin-angiotensin system. So there's ACE inhibitors, which are angiotensin-converting enzyme inhibitors, and that is part of a kidney problem related to hypertension. So if you inhibit the conversion of ACE or angiotensin-converting enzyme in the lungs, you can prevent the production of a vasoconstrictor, right? So hypertension is really just an imbalance in the vasodilatory versus vasoconstrictive molecules. So nitric oxide is the primary vasodilator. So ACE inhibitors, ARBs, calcium channel antagonists, and then diuretics to correct fluid imbalances.
Wow.
But there's something called resistant hypertension, right? And so 50% of the people that have high blood pressure that are put on prescription medication don't respond with better blood pressure. So why is that? It's because the root or the cause of their hypertension isn't related to their kidneys, isn't related to angiotensin, it's not related to calcium flux imbalance, and it's not related to fluid imbalance. What we've published on is that hypertension in many cases is a sign of oral dysbiosis.
Oral dysbiosis.
Yeah. So if you're using mouthwash, stop, your blood pressure normalizes. When you restore the ecology of the oral microbiome, your blood pressure normalizes.
What about just drinking alcohol? People who just, enjoy imbibing every once in a while. Does drinking alcohol, vodka, tequila, or whatever, can that disrupt the oral microbiome?
No, I'm a Scotch drinker.
You are?
I'm a social Scotch drinker. In fact, I love my Scotch. Here's the issue. If you were to drink alcohol, vodka, Scotch, or whatever, and you hold it in your mouth for 60 or 90 seconds as you would an antiseptic, I mean, maybe. Because these are 40%, right, in the actual, but I mix mine with water, so probably what I'm drinking is maybe 10% alcohol.
Well, if there's anything I remember from 2020 and the whole like COVID hygiene theater, it's that you want the alcohol percentage has to be 60% or higher for it to be antiseptic or something. Did I just butcher that?
Yeah, no, I think that's probably right. Yeah. So what we're drinking, even if we were to hold the alcohol in our mouth for 30 seconds like we would a mouthwash, you're probably not going to get effective killing. But during COVID, everything they were telling us to do was basically making people more susceptible to COVID infection.
Crazy.
Like the antiseptic, the hand sanitizers and using all, that basically kills the microbiome. There were people telling you they used mouthwash and antacids and all that. I mean, you're making the patient more susceptible to COVID infection.
Wild. Yeah, that was a crazy time. And there was just that review published in it was like Exercise Physiology, one of these journals, where they said that exercise literally is like the ultimate, most ideal first line defense.
For sure. Look, when I feel like my body's getting weak and I feel like I've got an onset of an illness coming, first thing I do, the last thing I want to do is go to the gym, but the first thing I do is go to the gym.
Wow.
And I exercise, I do 30 minutes of cardio, and then I go sit in a sauna for 30 minutes. And I haven't been sick in more than 20 years.
Sauna boosts nitric oxide, does it not?
Yes, red light, there's certain wavelengths of light that will stimulate nitric oxide production.
Red light. So I have a red light device. Is that's boosting nitric oxide when I use that?
So what's happening is there's what we call, and we published on this, I believe, in 2001, they're photolabile stores of nitric oxide that you can activate. So when nitric oxide is produced, it has certain cellular targets. It can bind to metals, it can bind to cysteine thiols. And so infrared light will actually liberate nitric oxide bound to metals. And then if you look at infrared or ultraviolet light, it'll cleave NO bound to cysteine thiols on proteins. So when you get exposure to sunlight, you're getting both UV, you're getting infrared, and you're releasing nitric oxide.
Wow.
But the problem is, if you're deficient in nitric oxide, you're deficient in these photolabile stores of nitric oxide. So if you've got a sick patient who can't make nitric oxide, red light therapies, there's no nitric oxide to release. So what we do is we try to titrate up the nitric oxide. So you either take our lozenge or our beet powder and then expose to red light therapy. Now we're going to potentiate the effects of red light therapy. You're going to potentiate the blood pressure lowering effects of sunlight or exposure to different light sources.
Wow. But if your oral microbiome is intact and healthy and you regularly eat dark leafy greens, then there's a synergistic effect.
Absolutely.
That you get in terms of nitric oxide synthesis with red light exposure, sun exposure,
right.
Et cetera.
Yeah. You need nitrate, you need bacteria, and you need stomach acid.
Wow.
Without either three, if one of those is missing, you don't get the effects.
Do you think the carnivore diet is a terrible idea?
No, I think different people respond to different diets. I'm not a big fan of extreme diets perpetually. I think you can make some changes in human physiology and metabolism by these drastic changes. So I'm not a big fan of a straight vegan diet. I'm not a big fan of a carnivore diet forever. So I think you can do intermittent changes in this and see the benefits. But from what I know about science and agronomy and nutrient assimilation in vegetables and nutrient assimilation in animal proteins, is we get the many nutrients and minerals that we need from a balanced diet, from a diverse diet. I think that's how we as humans have evolved. We get our nutrients from many different dietary sources.
Well, it's like they're not getting these inorganic nitrates.
There's really not. I mean, I think we published on this in 2015. There's very little residual nitrate or nitrite in animal meats, in meat products. And so the animals we eat are vegetarians, right?
Yeah.
Yeah. Right? So they're assimilating. They're plant-based. So they're assimilating the nitrate from the grass and the vegetables they're eating into their own tissue, muscle tissue. So even non-cured meat, non-processed meats, like a ribeye steak or things that's unprocessed, has some nitrate and nitrite in it. It's very little,
wow,
but it's there and it's detectable.
Ribeyes are my love language.
Yeah, mine too.
Yeah, love them. There's also, correct me if I'm wrong, there's a role for some of these carnonutrients like CoQ10
right.
in terms of recycling, right? Nitric oxide. So it can make a little go a longer way, hypothetically.
Well, there are a number of, the human body is redundant by nature, right? So there's enormous redundancy in the human body. In fact, if there was only one way to make nitric oxide, then probably humans would become extinct. So there has to be numerous ways to make this critical molecule. And there are different ways to recycle it and extend its biological half-life. That's kind of what we've harnessed in our therapeutic program and in our product development. So once nitric oxide is produced, it's gone in less than a second. In fact, the half-life of nitric oxide in the human body is 2 milliseconds.
Whoa.
So, but we can extend the biological half-life of this by understanding the metabolic kind of hierarchy of nitric oxide. Where does it go? What does it become? And what does it do? And so if we can capture that in form of a product technology or a therapeutic, then we can extend the biological half-life from 2 milliseconds out to tens of minutes and hours. We can do this through giving sulfur compounds like glutathione, polyphenols. You mentioned CoQ10. CoQ10 is extremely important for mitochondrial function. Nitric oxide is what controls and regulates mitochondrial ATP production, maintains the electrical potential across the mitochondria so it can generate ATP and produce less superoxide and oxidative stress. And nitric oxide is what controls mitochondrial biogenesis. So again, we can induce all these pathways, but if you don't have enough CoQ10 and all these mitochondrial cofactors, then the mitochondria are going to be dysfunctional. So in that case, it's not a nitric oxide deficiency, it's a mitochondrial issue. So again, we have to give the body what it needs, the body incorporates what it needs and does its job.
Beyond cardiovascular health, are there other areas of well-being that nitric oxide influences, like immune function, for example, inflammation?
So we learned a lot. There's a rich literature on nitric oxide and immune function. In fact, one of the first discoveries of nitric oxide was in macrophages and this whole reaction of arginine to nitric oxide to nitrate. This was back in the probably mid-'80s. So our immune cells make nitric oxide. And the whole purpose of this is when we're exposed to a pathogen, whether it's a virus or a bacteria, then our immune cells recognize that. Our cardiovascular system mobilizes an immune response. So we get the immune cells to the site of attachment or infection. And then these immune cells surround that and generate a ton of nitric oxide.
Wow.
And this nitric oxide binds to the iron sulfur centers of bacteria, shuts down their respiration, kills the bacteria, and it prevents the virus from replicating. So even if we're exposed to a virus, if our immune system is strong, it generates nitric oxide, we don't get sick from the virus.
Wow.
And this was what we recognized in probably March of 2020 in COVID, that the people that were getting sick and dying from COVID were the people who couldn't make nitric oxide.
Wow.
So who was this? So the elderly, people with a prior heart attack, diabetes, African Americans, people with pulmonary hypertension or smoked. These were the people that if they got exposed to COVID, it was a very predictable sequence of events. Within 3 days, they were sick. Within 4 to 5 days, they were hospitalized from low blood oxygen saturation. 5 to 6 days later, they were put on mechanical vent. 10 days later, they were dead.
Man.
I mean, this was very predictable. So that's what initiated us to start our drug trial for COVID. So we had a nitric oxide drug in phase 3 clinical trials for COVID.
Wow.
We filed our investigational new drug application in June. FDA approved it in July. We started enrolling patients in December of 2020. And we were making people better, but at that time, COVID changed, right? The hospitals weren't overrun with patients. These newer strains that evolved were less virulent, and people weren't going to the hospital. So our trial design was to reduce hospitalization by 20%. So we were enrolling high-risk patients and seeing if we could create an early treatment to keep them out of the hospital, keep their blood oxygen saturation up, prevent virus replicating. And we did this, but the problem was in the patients that we were enrolling, no one was going to the hospital, even the ones on the placebo, because they were getting the milder form of the disease. But here's what we've learned, and I'm probably the best example. Since March of 2020, I've been on an airplane probably every week for the past 4 years. And at one time, we had 26 COVID clinics around the U.S. So we would go in, enroll patients. I didn't wear a mask. I was almost thrown off airplanes for not wearing a mask. I didn't get the jab. I've never had COVID.
You've never had COVID?
Never had COVID.
Wow.
In fact, I haven't been sick from any infection or sickness since 2001 when I got the flu vaccine when I was at Boston Medical Center.
Damn.
So it's not that I'm not exposed to these pathogens. I'm exposed every day.
Yeah.
But my immune system is robust. I make a lot of nitric oxide, and if I'm exposed, we shut it down at the source of infection. We prevent it from replicating and propagating and making people sick.
Wow. Fascinating. And what about a lot of people today struggle from generalized low-grade chronic inflammation.
Well, if you look at, so mechanistically, in terms of inflammation, it's very well defined in science. Most people just think, well, you're inflamed, right? They see it as the silent killer, which has been known for many decades. So there's different markers of inflammation. One is high-sensitivity C-reactive protein that you can measure in the blood. In fact, one of my patents in our nitric oxide is a method of reducing C-reactive protein.
Wow.
So nitric oxide, and we published on this in 2009, that nitric oxide reduces the inflammatory response, reduces C-reactive protein. And when we look at inflammation, the earliest stages of inflammation is called microvascular inflammation, when the blood vessels become like Velcro. right? Platelets stick, monocytes, neutrophils stick, and then they infiltrate into the intima. They develop oxidative stress, immune dysfunction. You get plaque development, the plaque ruptures, heart attack, and stroke. So the sequence of events physiologically are very well defined. If you can inhibit that early microvascular inflammation, you can inhibit the onset and progression of cardiovascular disease.
Wow.
And that's what nitric oxide does. That's the reason it's so effective in COVID. You know, whether you give inhaled nitric oxide, and there were a number of clinical studies, that nitric oxide prevents the upregulation of adhesion molecules. So the spike protein binds to the ACE receptor. If you're nitric oxide deficient, you get an upregulation of the ACE receptor, so there's more targets for the spike protein to bind to. That causes further vascular inflammation. Platelets start sticking, get an elevation in D-dimer, microclots. So everything we know about COVID and long COVID and the systemic disease of COVID can be traced back to a lack of nitric oxide.
Wild. Is there a risk from bumping your nitric oxide too high?
Yes. As with everything, it's dose dependent.
Yeah.
Right? Too little NO is bad. Too much can be bad.
Hmm.
There's only two signs of toxicity. One is low blood pressure. If you take too much nitric oxide, you get systemic vasodilation, and you'll lose perfusion pressure.
So is it safe to say that somebody with, for example, POTS, is probably has could they potentially have too much nitric oxide?
I think that's an autonomic disorder, not necessarily related to the overproduction of nitric oxide. It's an autonomic nervous system disorder where they lose the ability to control, blood pressure upon sitting and standing.
Yeah.
It's an autonomic nervous system issue. The only time you see, and again, if you go back 20 years, people thought that when you get sepsis, right, when you get systemic infection and septicemia, that the reason people die from sepsis is hypoperfusion of organs. So it was thought that when you have an active infection, the immune cells are generating too much nitric oxide, you're getting systemic vasodilation, leading to loss of perfusion pressure, end organ failure, and death. So in 1998, they developed a clinical trial to give a nitric oxide inhibitor to septic patients with very good reasoning, right? If you're making too much nitric oxide, if you inhibit it, can you prevent the loss of blood pressure and save people's lives? Well, a very unpredictable occurrence happened that when they gave a NOS inhibitor, it killed more people than the placebo. So that told the scientific medical community that the death from sepsis and septicemia is not due to an overproduction of nitric oxide. So now we struggle with trying to find kind of a natural physiological condition where there's overproduction of nitric oxide. And I don't think that exists. But certainly you can take too much NO and you'll lose a loss of, your blood pressure will drop, or you develop what's called methemoglobinemia. So you'll oxidize the iron in hemoglobin of the red blood cells, and then you lose the oxygen carrying capacity of the red blood cell. And you become cyanotic. So you'll get blue around the lips.
Whoa.
You'll lose color. But that's a whopping dose. You'd need, it's typically 100 to 1,000 times higher than what you would ever get from a diet or from any product.
Yeah.
And you will develop low blood pressure long before you develop any methemoglobin formation.
I mean, most of the people today, like the problem facing most Westerners is hypertension. It's high blood pressure, not the inverse.
Well, there are people with low blood pressure, and that's typically a thyroid issue. Hypothyroidism causes low blood pressure. So then you got to fix, and the good thing about our product technology, and we tested this early on, is if you have low blood pressure and you take one of our lozenges, does it further reduce your blood pressure, causing syncope and lightheadedness? And the answer is no. So my blood pressure is typically, 115/72 at any given time, and I take a lozenge, doesn't change it. We've done 24-hour ambulatory blood pressure, and it doesn't. If you have normal or low blood pressure, it doesn't change your blood pressure. If you have high blood pressure, it'll normalize it. So that's one of the remarkable things about delivering nitric oxide at the right dose over the right amount of time. It's regulatory by nature.
Man to man, you take one of those lozenges before sex. What happens?
Well, we improve perfusion, right? I mean, we're leading to not only dilating the resistance arteries, but opening up the microcirculation. And so in the sex organs, it's a spongy tissue, right, with a lot of small blood vessels. So when we can improve the perfusion and open up those micro circulation and small blood vessels, we get better perfusion, better engorgement, better erections.
Are there clinical trials? I mean, does it like how would it work in comparison to a drug like Viagra, for example?
Well, again, let's go back and talk about how Viagra was discovered and put into clinical practice. These drugs early on were developed for patients with pulmonary hypertension and for ischemic heart disease. So the whole rationale is, so these drugs are called phosphodiesterase inhibitors. Nitric oxide, once it's produced, causes an increase in a second messenger called cyclic GMP. And Viagra prevents the breakdown of the second messenger. So now, like I said, nitric oxide turns the switch on, and Viagra keeps it on. And that's the reason you're warned against a 4-hour erection and headaches and loss of vision and all these side effects.
Yeah.
But 50% of the men that are given Viagra don't respond with better erections.
Interesting.
So it's been on the market for 25 years, multi-billion-dollar-a-year drug that only works in less than 50% of the men.
I thought it worked in everybody.
No. 50% efficacy in men with ED or symptoms of BPH, benign prostate hypertrophy. So mechanistically, we understand why that is, because you need nitric oxide for Viagra to work. And if you can't make nitric oxide, there's no increase in cyclic GMP, so there's no substrate for these drugs to work on.
Got it.
And we did a clinical trial years ago where we took non-responders to PD5 inhibition therapy. We were using, I think, patients who were on 5 milligrams Cialis once daily for either erectile dysfunction or BPH. And those that were non-responsive, we actually made them responsive by giving them the nitric oxide.
Damn, so you take one of your lozenges and a Viagra and you're just ready to party?
Yeah, be careful though.
Damn.
You can overdo it, yeah. So the whole point is, if you understand mechanistically what causes vasodilation, what causes improvement in sexual function and erections, then you get to the root cause of it. You don't need phosphodiesterase inhibitors to improve sexual function. What we're finding is if you just improve nitric oxide production, all the downstream signaling aspects of that take care of itself. You generate nitric oxide, you activate guanylyl cyclase, you increase cyclic GMP, you get vasodilation, you get an erection. It's that simple.
And as you mentioned earlier in the episode, benefits women as well, right?
Yeah, look, they need engorgement and erections as well. It's a clitoral erection instead of a penile erection, but it's the exact same. The anatomy is a little bit different. The physiology is exactly the same.
Yeah. Damn. More nitric oxide for everybody. I feel like the world would be a better place. We'd all be happier.
Well, we're working on that.
Working on it.
And thanks to you, we're going to educate more people on the importance.
Yeah, man. My mind is always blown whenever I get to sit down and chat with you. And I failed to mention this earlier in the episode, but I actually quote you in my third book, Genius Kitchen, as well. In the section about mouthwash.
Yeah.
Yeah.
Now that's always the aha moment for people. I mean, because people have good intent, I think. They see the adverts on TV, they go to their dentist and they think, well, I need to have clean breath, fresh smelling breath, but they don't understand the collateral damage causing.
Yeah.
It's like dropping an atomic bomb in your mouth. You're killing the bad guys, but you're killing the good guys too. And
not only that, but the good guys probably police the bad guys to
that's exactly right.
Right? To promote good breath.
It's the whole ecology. There are different communities of bacteria on the gingival tissue, on the tongue. There are biofilms, different layers. And so as long as you have a good, healthy, diverse oral microbiome, the good guys keep the bad guys at bay. When you disrupt that, you cause chaos, then the bad guys take over, and now the inmates are leading the asylum.
Damn. All right, so let's just do a recap, because I feel like there's so much incredible information here, and people should definitely go and follow you on the socials and check out your products and everything, because this is really groundbreaking science that you're sharing. But for those interested in optimizing their nitric oxide levels, let's just in a sort of Cliff Notes format recap. What actionable steps or advice would you recommend?
You got to do two things. It's only very simple. Stop doing the things that disrupt it. Start doing the things that promote it. So what is that? Stop using mouthwash. The evidence is abundantly clear. For me, everything's about risk-benefit. What are the risks versus the benefits? Mouthwash, there's really no benefits. The risk, high blood pressure, loss of the protective benefits of exercise, and probably ED, and the whole sequela of things that happen with nitric oxide deficiency. You have to get rid of fluoride. Buy fluoride-free toothpaste, get rid of fluoride in your drinking water and your home health system or home water system. And then if you're using antacids, you have to stop. So those are three biggies. Fluoride, mouthwash, and antacids, you have to completely get off those, because that's inhibiting the body's ability to make nitric oxide on its own. And then there's no need for product technology unless you're not doing the other. So if you stop doing those three things and you just get 20, 30 minutes of physical exercise a day, it can be a brisk walk, then more green leafy vegetables or a nitrate source. I recommend a balanced diet in moderation. And then sunlight, or the red light therapy, or you get broad spectrum, full spectrum from sunlight. So I'm a big fan of, just sitting 20, 30 minutes out in the sun a day. And then when all else fails, then we have products that do it for you.
Love it. Super useful. With regard to oral care, are you a fan of hydroxyapatite, like some of these fluoride replacements?
I think there's a spot for that, again, and everybody's different, right? So hydroxyapatite is kind of like a substrate that helps build strong teeth and bones. There are a lot of things we don't know still. People ask me all the time about oil pulling, essential oils, different oral hygienic practices, tongue scraping. In 2019, we published that if you tongue scraped, that the people who did tongue scraping seemed to have a higher diversity of the oral microbiome, which seemed to be a good thing, and they had better blood pressure management. But if you tongue scraped and used mouthwash, those were the people we saw the highest increase in blood pressure on.
Wow.
So I think tongue scraping alone is probably good. We just don't know about things like hydroxyapatite, how they're affecting the microbiome. We don't have any data on things like essential oils or oil pulling. But I think as long as they're not antiseptic, then it's probably going to be fine. You have to support the ecology of the oral microbiome and let these bugs do their job.
Great advice. Nathan Bryan for president.
Not yet.
Dude,
I got other work to do.
I know, you do. You do. Yeah, there's a lot of work that needs to be done. But fascinating stuff, man. Thank you so much for coming back.
Thank you, Max.
Hey, if you liked that video, you need to check out this one here, and I'll see you there.